See, now after understanding the theory part of capacity planning, we are in this today's lecture we are going to start the numericals. But before starting the numericals, what I have done is I have listed the formulas. This is the list of formula which starts from first formula till the eighth formula. This is the list of formulas which will be used while solving the problems on capacity planning. First, what we will do is we will try to understand each and every formula, and after understanding of the formula we will go for the problems one by one. The first formula is like this. Suppose we want to do a processing on a particular units in hours. In hours we want to do, and we have annual demand given in units, and number of hours required to process one unit. So if we multiply the number of hours, number of units, if we multiply number of units with time for processing one unit, we get the processing needed in hours. Now, as many times it happens that in the questions of capacity planning, what they do is they many times in numericals what happens is they give you that a company is working for this much hours in a day, and out of 365 days in a year it is working for this much amount of days. Means they give you number of working days, say for example 270, 285, 290 out of 365, and in a single day how much hours it is working they give you. Based on these two, if we multiply these two, we can able to find out the annual production capacity of one machine. This is the simple formula for it. What they give you is they give you out of 365 days in a year how much amount of days we are working, say for example 270 to 85, and they give you in for a single day we are working for 8 hours or 10 hours, and if we multiply these two we get the annual production capacity of one machine. Now the third formula which we want to understand is workload per year. Number of workload per year is given to you. What do you mean by workload per year? In simple terms, if you understand what is the meaning of workload per year, adding all the processing needed given to you in the question, which is the first formula. If we add all this processing needed, say for example 4 processing needed are given to you, and if we add all this we get workload per year. And as it is clear that the part which is coming into the denominator, that is production capacity per machine, can be easily found out by using the second formula. So if we divide the sum of processing needed, which is workload per year, by the production capacity per machine, we get number of machines required to do the production. This is the simple meaning of third formula. Now if we go for the fourth formula, if we understand this, it is nothing but we are trying to find out the efficiency of the plant efficiency we are interested in finding out. So the simple thing which we need to understand here is, for finding the plant efficiency we should know what is the actual output the plant is producing, and what is the effective capacity. I have already explained this part in theory, that effective capacity involves some amount of cost and all other factors which are utilized optimally to achieve the targeted production in a stipulated time. So if we divide these two, we can get efficiency of plant. Now coming back to the point, formula number 5th, which is utilization. What utilization? Amount of work utilization in percentage. It is nothing but what many students get confused in this formula, that utilization means what? Utilization is nothing but utilization of plant, that how much amount of capacity of the plant is being utilized. So as usual, I have told you already that if we want to find out the efficiency as well as the utilization, we need to know the actual output. Then and then only we will be able to find out the efficiency as well as the utilization. So if we know actual output and we know design capacity, first of all try to understand the difference between effective capacity and design capacity. In simple terms, if you understand, effective capacity is a capacity which a company or a firm expects to achieve by having the current business conditions, means everything is not idle, something is lagging, something is there, some resources are lagging. Say for example, man and money is there, material is not there. So what I want to say is the capacity. What is effective capacity? It is the capacity which is achieved, or which a firm expects to achieve under actual business conditions. Actual business conditions means whatever there is in the current field. But if we try to understand the meaning of design capacity, what design capacity means, it is nothing but the output a system or a firm can achieve under ideal conditions. If everything is idle up to the mark, how much amount of output we can achieve is nothing but the meaning of design capacity. So if we divide the actual output by design capacity, we get the percentage utilization. Now the next formula is bottleneck. What do you mean by bottleneck? Suppose there are 4 systems or 4 processes having values of 300, 350, 400 and 450. So the value of 300 will be considered as bottleneck. In simple terms, if we understand. So what happens is that if the question comes in the examination, many students get confused that what is the meaning of bottleneck. Bottleneck is simply, in simple terms, if you understand, it is the process which has the minimum capacity or minimum capability to produce the number of units. Whatever example I have given you, 300 will be the bottleneck if we assume or compare the 4 values, that is 300, 350, 400 and 450. 300 will be the bottleneck. Now coming to the formula number 7. Now if we understand the formula number 7, quantity break even. Quantity break even, in simple terms, if you understand this formula, we have used in marginal costing only also, but I am repeating here. It is nothing but fixed cost divided by revenue per unit minus variable cost per unit. This is the formula for which I want to explain you. After this, the last formula comes is of system efficiency. What do you mean by system efficiency? Again the same thing, actual output upon system capacity. If you understand here, the actual output, this part is common for finding out the system efficiency, as well as for the utilization part, as well as for the efficiency of plant. It is common for all the things if you understand this.